Hello, and welcome back to the channel. Today, we're sinking our teeth into one of the most fascinating aspects of the prehistoric world, the evolution of dinosaur teeth and their diets. How did these incredible creatures go from simple, pointy-toothed hunters to a diverse group of specialized eaters, from gentle giants to bone-crushing predators? It's a story written in fossils, and we're going to decode it together. Let's travel back to the Triassic period, over 230 million years ago. The earliest dinosaurs, like Eoraptor, were small, nimble, and had relatively simple teeth. Imagine small, sharp, conical pegs lining their jaws. These weren't highly specialized tools. They were general-purpose implements, perfect for snapping up small lizards, insects, and whatever else they could catch. These teeth tell us that early on, the dinosaur menu was pretty straightforward. If it was small and moved, it was probably food. They were opportunistic carnivores, the pioneers of the dinosaur dynasty, setting the stage for the incredible diversity that would follow. As we move into the Jurassic period, things start getting really interesting. This is when the dinosaur world truly exploded in size and variety. On one side, you have the carnivores, the theropods. Think of Allosaurus. Its teeth were like curved, serrated steak knives. They were large, recurved, and designed for one thing: slicing through flesh. When an Allosaurus bit into its prey, these serrations would have helped it tear away huge chunks of meat. The shape of the teeth, curving backwards, also helped to hold on to struggling prey, preventing it from escaping. They weren't for chewing, but for ripping and swallowing. But the Jurassic wasn't just about the meat eaters. It was the age of the sauropods, the long-necked giants like Diplodocus and Brachiosaurus. You'd think a creature that massive would need some serious grinders, right? Well, not exactly. Diplodocus had slender, peg-like teeth clustered at the front of its mouth. What were these for? Paleontologists believe they were used like a rake or a comb, stripping leaves and needles off branches. They would have just pulled the foliage into their mouths and swallowed it whole. No chewing involved. Their bodies did the hard work of digestion later, possibly with the help of gastroliths or stomach stones to grind up the plant matter in their gizzards, much like some modern birds. Brachiosaurus, on the other hand, had more robust, spoon-shaped teeth. These were better suited for nipping off tougher vegetation. Its high-browsing lifestyle, reaching up into the tall conifers, meant it needed teeth that could handle a more resilient meal than just soft ferns. The difference between Diplodocus and Brachiosaurus teeth shows us a key evolutionary principle: niche partitioning. Even among giant herbivores, they evolved different tools to eat different types of plants at different heights, allowing them to coexist without directly competing for the exact same food source. It was a brilliantly efficient ecosystem. Now, let's fast forward to the Cretaceous period, the final act for the non-avian dinosaurs. This is where dental evolution really goes into overdrive. Let's start with the king himself, Tyrannosaurus rex. T-Rex didn't have steak knife teeth like Allosaurus. It had something far more terrifying. Its teeth were like giant, thick, bone-crushing railroad spikes. They were robust, conical, and deeply rooted in its powerful jaw. While they had serrations, their primary function wasn't just slicing flesh, but pulverizing bone. Fossil evidence, including T-Rex bite marks on Triceratops bones and even fossilized T-Rex dung, containing bone fragments, confirms this. T-Rex was a bone crusher, capable of exerting immense bite force to get at the nutritious marrow inside. It wasn't just eating the steak, it was eating the whole meal, bones and all. Meanwhile, the herbivore game was changing dramatically too. The Cretaceous saw the rise of the hadrosaurs, or duck-billed dinosaurs, like Edmontosaurus. And their mouths were a true marvel of evolution. They didn't just have a few teeth. They had hundreds, packed together into what's called a dental battery. Imagine a whole surface made of interlocking teeth. As the top layer of teeth wore down from grinding tough plant material, like flowering plants, which were new on the scene, new teeth from below would continuously erupt to replace them. It was like a self-sharpening, ever-renewing grater. This allowed them to chew their food incredibly efficiently. A huge advantage that let them process a wide variety of tough vegetation and thrive across the Cretaceous world. And we can't forget about the horned dinosaurs, the ceratopsians. Like the famous Triceratops, They also developed dental batteries, similar to the hadrosaurs, but their mouths worked a bit differently. At the front, they had a sharp, powerful beak, perfect for shearing off tough cycads and ferns. Then, further back, the dental batteries would slice and dice the plant matter like a pair of garden shears. The vertical shearing action of their jaws was a highly effective way to break down the fibrous plants that made up their diet. So you have the beak for snipping and the batteries for slicing, a two-stage food processing system right in their mouth. From the simple pegs of the first dinosaurs to the bone-crushing spikes of T-Rex and the incredible dental batteries of the hadrosaurs, the evolution of dinosaur teeth is a perfect window into their lives. Every shape, every serration, and every arrangement tells a story of adaptation, of a planet teeming with life, and of a 150 million year long evolutionary arms race between predator and prey, and between plant eater and plant. By studying these fossilized teeth, we can reconstruct entire ecosystems and understand how these magnificent animals didn't just survive, but absolutely dominated their world. Thank you so much for joining me on this journey back in time. It's truly amazing what a single tooth can tell us. If you enjoyed this deep dive into the world of dinosaurs, please hit that like button and consider subscribing for more adventures into the prehistoric past. Let me know in the comments which dinosaur's teeth you find the most fascinating. Until next time, stay curious.